Before starting the video, here's one question for you. Do you know what Aditya L1 means? Think about it and comment below. If you still didn't get the answer, watch the video till the end. There are a lot of things that scientists and astronomers are yet to learn about our closest star, the Sun. So, in order to grasp out more knowledge about the Sun, the Indian Space Research Organization or ISRO have planned and decided to launch a mission called as Aditya L1. So, what exactly is this Aditya L1 mission? Well, let's find out. Aditya L1 is a solar coronagraph mission scheduled to launch in month of December this year. The major scientific objectives of Aditya L1 are to achieve a fundamental understanding of physical processes that heat solar corona, accelerate the solar wind, and produce coronal mass ejections or CMEs. In order to achieve these objectives, the spacecraft is equipped with various payloads. First of this equipment is Visible Emission Line Coronagraph. The 170 kg payload will study the diagnostic parameters of solar corona and dynamics and origin of coronal mass ejections. The second payload is called as Solar Ultraviolet Imaging Telescope. The telescope will observe the Sun between 200 to 400 nanometer wavelength range and will provide full disk images of different layers of solar atmosphere by making use of 11 filters. Aditya Solar Wind Particle Experiment is another equipment which will be used to study the variation and properties of solar wind as well as its distribution and spectral characteristics. Another equipments which will be attached to the Aditya L1 spacecraft are Plasma Analyzer Package for Aditya, Solar Low Energy X-ray Spectrometer, High Energy L1 Orbiting X-ray Spectrometer and Magnetometer. These equipments will be used to understand the composition of solar wind, monitor the X-ray flares for studying the coronal heating mechanism, to observe the dynamic events of solar corona, and to measure the magnitude and nature of interplanetary magnetic field respectively. The Aditya L1 spacecraft is 3-axis stabilized, consisting one solar wing with two panels using Indian mini satellite bus of Saral. The spacecraft is developed as a standard satellite bus by ISRO Satellite Center. The structure of Aditya L1 consists of aluminum skin honeycomb sandwich structure with localized corner brackets at top. The total mass of spacecraft including the payload is expected to be around 1500 kgs. The spacecraft will use an altitude and orbit control system which consists of various types of sensors for measuring of altitude errors, control electronics and different types of actuators. The sensor system consists of a star sensor, sun sensors, magnetometer and the inertia referencing unit, which includes 3 miniature gyroscope and dynamically tuned cluster mounted vibration isolators. The spacecraft using PSLV-XL will be inserted in a halo orbit around the Lagrangian point 1, which is 1.5 million kilometers away from Earth. Now, having a spacecraft at Lagrangian point 1 gives the spacecraft an opportunity to perform observation without any interruption in the view of the Sun. Before moving on, here is the answer to the question asked at the start of video. Aditya L1 is a combination of word Aditya, which means the sun in Sanskrit, and L1 is referred to the position of spacecraft, that is Lagrangian point 1. Now let's continue where we left off. If this mission becomes successful, many unanswered questions including how the corona gets heated to such high temperature, even though its lower atmosphere remains relatively cold, can get solved. The spacecraft will also try to provide observations of Sun's photosphere and chromosphere. The mission will also try to obtain near simultaneous images of different layers of Sun's atmosphere, which will reveal the way in which energy can be channeled and transferred from one layer to another. Thus, the Aditya L1 mission will enable a comprehensive understanding of the dynamic processes of the Sun and also will try to solve the unsolved mysteries of the solar physics.